Welcome to series of database management system video lectures. Today we will be discussing about unit 4 and topic 5, that is relational calculus. Before this we have relational algebra topic which we have already covered as part of unit 1. So we have discussed what are the various operators that are used as part of relational algebra. So I suggest you to refer to unit 1 relational algebra video so that you can finish the topic even in unit 4. Now, moving on to the next one, that is relational calculus. Now, what do we mean by relational calculus? Relation here is a table of data, and then performing calculus upon that particular data item is nothing but retrieving the actual data, and then how do we get the data? What can be the various operations that are going to be applied to get the required amount of data? Okay. So now, relational calculus is a non-procedural query language. Now, what do we mean by non-procedural language? Let us come back one step. So, in the previous session, that is Unit 5, we have learned about structured query language. So, structured query language is a procedural query language. Okay, we have used a particular set of commands or the syntax to construct the query in order to retrieve or fetch the data from the database. So relational calculus is completely different compared to the structured query language. It is a non-procedural language, so we do not follow a particular pattern to write the commands. Okay, so in the non-procedural query language, the user is concerned with the details of how to obtain the end results. So in the structured query language, we will try to find out how the data can be retrieved. Whereas in relational calculus, we try to see that what kind of data, what data is going to be retrieved. Okay, so the relational calculus tells us that what to do, but it will never explains how to do. So what has to be retrieved from the given set of data items? That is going to be defined by using relational calculus. Whereas in relational algebra as well as in structured query language, we try to focus upon what has to be done in order to retrieve the data. Okay. How it can be retrieved, what can be the various operations that can be performed upon the data. That is going to be learned as part of procedural query language. Now, so these relational languages are based on the aspects of relational calculus, which includes query by example. Okay. Now, what do we mean by a procedural language and then declarative language? Procedural language, which we have used so far, are going to focus only on how to get the results from the given set of data items or from the database. Whereas in declarative language, we do not focus on how to get the results, but then in fact, what has to be retrieved when we perform one particular query, what has to be retrieved. Now, the examples of the procedural languages here is relational algebra. And whereas it comes to a declarative language, we have the example that is relational calculus. I think from this particular point, it is clarified that what do we mean by a procedural language and a declarative language. Procedural language simply tells us how to get the results from the database. Whereas in declarative language, that is relational calculus, it just defines what has to be retrieved. Now, why it is called as relational calculus here? As we have already discussed what is relational algebra and the definition of relational calculus, right? So now this calculus is a term which has been taken from mathematics background. So applying mathematics upon the relational data in order to extract the data. So what has to be retrieved from the database is going to be defined by the relational calculus. Okay, so let us revise the point here. Relational calculus is used to manipulate and describe the relational data in database management system using a mathematical and logical approach. The relational part refers to representing an organization of data in tabular form with the help of relations or tables. And the calculus part signifies a system of calculation and reasoning. So that's the reason relational calculus is based on predicate calculus, that is a truth-valued function with a set of arguments. Now, we will put the same relational calculus in the form of a mathematical representation. Let us look at here. To represent that in a mathematical notation, we need few set of special symbols that helps us to better represent how the data is going to be retrieved and in what manner and what the data has to be taken. So here, and this particular special symbol represents and this is or, this represents not. So these three are related to truth table. Okay, and this is belongs, epsilon represents to belongs to, and this is for all, which represented as universal quantifier, which is going to represent a set of records which are going to satisfy the given condition. And this is there exists is a special symbol which is going to represent that from the given set of tuples, at least one occurrence of the record is going to satisfy the given condition. So this is called as universal quantifier, and this is also a universal quantifier. These are the set of notations that are going to be used in order to represent a relational calculus. So we have types of relational calculus. One is TRC and then DRC. TRC represents to tuple relational model calculus, and DRC represents as domain relational model calculus. So tuple relational calculus deals about only the set of records. We focus upon what has to be retrieved from the set of tuples. Domain relational calculus is going to focus upon the columns or the domain of that particular records. So the condition which we mention is going to be related to the column or the record. So as we have already discussed about what is relational calculus, let us get into deep about a tuple relational calculus. Here it focuses on what record has to be retrieved from the given set of records. So this is the mathematical notation of specifying tuple relation, wherein the lowercase letter t represents the tuple, the set of records from the set of records in the given table. Okay, so the condition is going to be mentioned here in P of t. So whatever may be the records which are going to satisfy to that particular condition, the records are going to be represented by T here. So tuple relational calculus describes the desired information without providing specific information for obtaining that information. So we are not going to be very specific that I wanted to retrieve only that set of student records whose marks are. So I'm going to be very specific in retrieving that particular condition. Okay. Now, let us take one example. Here we have a ninja table with the two attributes, so that is ninja name and then course enrolled. So let us write a tuple relational query to get the data of all the ninjas whose age is greater than or equal to 70. So now let us write this particular record. So T represents the set of records or the tuples which are going to be retrieved based upon the given scenario. So here this set of records are belonging to table called as ninja, and we are applying every particular record. So that's how the condition is taken as where age is greater than or equal to 70. So I'm just going to get a set of records which are going to match to this particular condition. So a group of records or tuples are going to be retrieved, but not very specifically one particular record. So that is the speciality of tuple relational calculus. Now let us look at the next, the result which is obtained from this particular query. Okay. Here I have age column as well. Only then we will be able to retrieve these set of records. We didn't add it here. And the next is, I wanted to get only the names of all the ninjas who are enrolled in C++ course. So here I have two records, okay, with who have enrolled into C++ course. So I wanted to retrieve only that set of records. So we can mention here, set of records, there exists the number of records which are belonging to ninja. So let the ninja name is equal to, the record name is matched to the name of the ninja where they are enrolled to the course called as C++. Right? So we will be able to get only ninja 5 and then ninja 4. Only those names are going to be retrieved. Right? Now, domain relational calculus, this is also similar to tuple relational calculus in terms of representation or notation, but the thing is, there we represent only a set of tuples, but then here we will be more considerate in taking the attributes of the table. Okay, so these attributes are going to be retrieved based upon the condition which is being matched there. Now let us take the table, the same ninja table with the ninja ID, gender, and then age. Now let us write a query, DRC query, to retrieve the data of all the ninjas whose gender is male. Okay. So now we represent x1, x2, x3 are nothing but the set of attributes, that is ninja ID, gender, and then age, and map it to x1, x2, x3. Now I wanted to retrieve the ninja ID and then age based upon the gender. So x1 and x3 are going to be taken as ninja ID and then gender. Okay. So now once after performing this particular query, we will be able to retrieve only the male related ninjas information. So we have CN1 and then CN4 with age 18 and then 17. Okay. So we will be writing the query in this manner instead of specifying the tuple records there. Now let us look at the next DRC query. Now I wanted to retrieve ninja IDs of all the ninjas whose age is lesser than 18. Lesser than 18, you have 16 and then 17. Only these two records are going to be retrieved. So I'm interested to retrieve only IDs of the ninjas. So X1 represents the first attribute, that is first domain. So X1 you are representing, wherein you are specifying the table name, that is ninja, and the condition is taken as x3 is nothing but the age which is lesser than 18. So we are going to retrieve the set of records. So this is how we deal with the domain relational calculus. Now, where do we apply this relational calculus and database management system? So far, we have learned how to write a simple queries, and to the next level complex queries were also being written using constraints upon the data members with respect to key attributes, right? And then we have even learned how to construct a complex queries based upon the cursors, triggers, and then procedures. Now, this relational calculus will also help us in formulating complex queries, which involves multiple number of tables, and we applied aggregation functions upon the set of data attributes and also the conditions. These are going to be very tougher, right? Before we apply that sort of thing, let us formulate it using a mathematical notation. Second use case is that relational calculus also helps us in data validation. It enables users to check whether the data is going to satisfy the given condition, and also helps us in identifying the errors or inconsistencies which are going to be generated. And thirdly, relational calculus plays an important role in database modeling as well as design. It helps us in designing the schema, integrity constraints, primary and foreign key constraints, and other things which are required in the detailed design of the database. And finally, this can be applicable, or this can be performed in advanced data analysis like sorting, filtering, aggregation, and grouping. This helps users to get meaningful insights from the large data sets. So these are the use cases where the relational calculus can be applied in a real-time scenario. And we have further drawbacks of relational calculus. The first one is this is not going to be that user-friendly, because we need to remember what is that mathematical notation and we need to follow that particular pattern, unless we will not be able to write the query in an easiest manner. Up to some extent, SQL query language were taken as more user-friendly because we have tuned to the set of commands. And that's how, which has purely written in English language, we will be able to memorize it and then easily recollect it. But then when it comes to relational calculus, writing DRC and then TRC needs a set of prior knowledge that what are the set of operators and what kind of data that have to be retrieved should be very much sure. And the query should not be so lengthy to retrieve the data. It should be made in a short or concise manner to retrieve the data in an efficient manner. The second drawback is that it is a declarative language which only focuses on what to retrieve that rather than how to be retrieved. Third one is it doesn't provide any mechanism which optimizes the queries automatically and does not support any recursive queries. So optimization technique is not going to be applied here, as we use the query optimizer for evaluating SQL language queries. And finally, it may not be suitable for dealing with semi-structured or non-relational data such as graph data or JSON documents. That is Java simple object notation documents, which are not going to be that easily used. That is, NoSQL data items are not preferably used with the relational calculus. So these are the drawbacks that we have with respect to relational calculus. So with this, the topic is completed. Thank you.